Welcome back to our installment of the landscapes of the Netherlands. Today we will be discussing peat landscapes. We've seen that in the north there is a landscape dominated mostly by heavy clays from the sea, and the other low-lying areas in the Netherlands that were not influenced as much by the overflowing of the ocean and the reclamation of the ocean, those were covered by peats. And peat landscapes are wetland landscapes. And when we talk about wetland landscapes, we talk about ecosystems on the border of lakes, sweet rivers, and terrestrial ecosystems. Now, just to refresh in your memory, what is an ecosystem? Think about this question for about 2 or 3 seconds and start to remember your biology. An ecosystem, of course, is basically this. It is essentially energetically open and materially sort of closed. The material here that doesn't go away. The tree, it may die, it falls down, it gets broken down by soil organisms, and then the minerals are nutrients for new plants. So there's, this cycle going on. But of course, it's energetically open because ecosystems are powered usually, most of the times, by the sun. There are some ecosystems that work with biochemical saluting of CO2 usually, and there are some bacteria who do it with energy from, for example, the earth itself in the black smokers, etc. But let's say that every ecosystem that we get to see and visit physically is going to be powered by the sun. Now, of course, it's relatively stable. There are some disturbances here. Let's say a fire comes by and burns a couple of these trees. Well, then the ashes release the minerals again, and eventually the trees will grow back, be it a little bit different. But the ecosystem, it is relatively stable. It will adapt to a new situation. There are countless feedback systems that keep the ecosystem robust, as the term is called. And of course, there are relations between biotic and abiotic elements. What I mean by that is that these animals, they are obviously biotic, and they have relations with the soil that they live in, which is the sand or the clays or the peats or the soil types. Those, of course, are abiotic elements, unless maybe peat, because peat is a plant, dead plant eventually. But the water, of course, isn't alive. So these fish, they swim in the water. If the water has a certain pH level, it's not really acidic, then, of course, there will be different types of fish there, and there will be different types of plants, and then the fish will live off different types of plants. So there are clear relations between the biotic and the abiotic elements, the plants, the soil, the amount of moisture, the quality of the liquid water that is in the ecosystem, etc. So we will be discussing wetlands as ecosystems. Now, what's a wetland? Well, a wetland is an ecosystem with a huge amount of water in them. And there are 4 types of wetland ecosystems, and there are 5 here on your screen. So what's the catch? Well, basically there's 3. There's the marsh, the swamp, and the mire. And the mire, there's 2 types of mires. So there's the bog and there's the fen, and they're both mires. Now, what's the difference between a marsh, a swamp, and a mire? Well, a marsh is a wetland ecosystem that's dominated by grasses on the edge of an aquatic and a terrestrial ecosystem. So say you have a river and the river overflows regularly because there are no dikes. Then you won't see any trees because the trees will rot away. They cannot deal with the excess water, and some grasses will grow there, some reeds, etc. Then we are dealing with a marsh. Now, a swamp is a wetland ecosystem dominated by trees. So a special type of tree that can grow in a lot of water, that's going to be a swamp. Shrubs, other plants with wood in them. So as soon as you see plants with wood, then you know you're dealing with a relatively stable swamp. Okay, then what's a mire? Well, a mire is a wetland ecosystem without trees or forests, and it's defined by peat peat-forming plants. These reeds and and grasses, they don't necessarily have to form peat. If they just die and rot away, completely dissolve, then it's not going to be a mire. A mire is a wetland ecosystem that forms peat. So certain types of mosses that keep the water in and make sure that when they die, they don't rot away because they have no reaction to the oxygen because it's covered in water and there is not enough oxygen in water to actually make that rotting process start. That is a mire, or also called a quagmire. Okay, the guy from Family Guy, the giggity, perverted sexual neighbor, that is named after a wetland ecosystem. Now there are two types of mires. Okay, there's a mire where the soil has very little nutrients in it and the water is quite acidic. We refer to that as a bog. So every time you hear me say a peat bog, it's a mire. There is going to be peat, and it's a special type because the water is acidic and there's little nutrients in it. A fen is where the water is pH neutral, let's say pH 6.5 to 7.5. It's going to be roughly around pH 7, and it's got lots of nutrients and soil in it. That is going to be a fen. So marsh and swamp dominated by grasses or trees, mires dominated by peat-forming plants, either bogs or fens. Now I'm going to use the terms bogs and fens basically as synonyms. We know that they're not, but mire, bog, and fen is going to be, one word when I'm talking about these, just to keep it simple a little bit. Here we have a example of a marsh. As you can see, it's mostly reeds and grasses, and there's a lot of open water here. So this is a marsh. On the edge here, there's a little bit of a forest. Now, that could be the beginning of a swamp, but more likely it's not. Okay, here we are in a swamp. This is a swamp area. Apparently, something has overflown, and this water cannot get away. These trees, they are adapted to the water. Shouldn't take too long, though. And these are found in the south of the USA very extensively. Every time you talk about Louisiana or the mouth of the Mississippi or the Everglades, this could be Florida, in the Everglades. And this is in the south of the U.S., this is where the alligators live. Now, this is a mire. Here we see it. No grasses, no trees, just peat-forming mosses and plants. So 3 examples. This is the schematic that you could think about. This is the lake, and in the lake there are plants growing. Some grow under the water, submergent. Some grow, sometimes under the water, but mostly above, the sparse emergent grasses and reeds and weeds. And then the dense emergence and the meadows. So this is all going to be the marsh area because, no trees. And then over this side where the first shrubs can grow and perhaps some first trees and the willow trees and the huge big trees, this is going to be the swamp area. And it doesn't overflow as regularly, okay? Now this is a coastal wetland, and they say that this is a lake, but we have seen this before in the kvelders, for example, where this is salt. This can be salt water as well. We've got saltwater marshes and saltwater swamps. Obviously, different plants grow there because not all plants deal with the salt very well. All right, so wetland areas. 3 main types. I am going to talk mostly about the mire type because that's what we are dealing with in the Netherlands. So peat bogs and fenlands are going to be one term, and they look sort of like this. And this was a huge part of the Netherlands due to the transgressions of the Holocene. We had an area where the water could not easily get away and was stagnant. And in stagnant water, plants can grow. And we've seen that before when we discussed peat formation. So I'm not going to go into that. I'm going to talk to you mostly about the cultural elements of the landscape. What people did who started to live in these peated landscapes. Now, you can imagine that it's going to be pretty hard to eke a living out of these types of landscapes, right? I mean, you can't put a cow there because these are the areas where there is quicksand. Cows can get stuck. You have to dig them out again, and if you're unlucky, your cow is going to walk into a quicksand area and just drown. So yeah, cows, sheep, they won't be able to live here. But what people did is they started to get rid of the water as quickly as possible, and they were very lucky because peat is actually, when you dry it, it's going to be dried, almost dead plants or dead plants most of the time. So you can put it, you can set it on fire, and it's good fuel. And so that's what they did. They started to eke out a living here by digging out the peat. But you have to make it dry first. So what they did is, on the basis of a river, usually a river that was already there, or sometimes they dug a canal, they started to build their farms over here and over there. And this river was then the reclamation base. And what they did is they dug channels deep, deep, deep into the peated areas. And these reclamation bases and drainage channels made sure that the stagnant water could flow away. And so the peat became drier. The peatland became drier. And here we have a picture of the cultivation of this area. So imagine that this is a huge peat swamp, or not a swamp, but a mire, a peat mire. And there are a couple of rivers, the Amstel over here, and the Waver over here. And these are just, small rivers in a peatland area. And what people did is, from these reclamation bases, they started to dig the channels into, and from this side also, into the peat, and made it suitable for cultivation. Cultivation, ontginnen, meaning getting it ready for agriculture. Get out the peats that are fuel, and make sure that you can actually do something with the land. Maybe, a couple of crops can grow there. Of course, to do this, you need to get rid of all the water. So how do you do that? Well, you dig a trench into the peat all the way, and get the water to go to these rivers, the Amstel or the Waver. But sometimes you are very far away. This is a couple of kilometers. So you have to dig another one over here, the main sloot in this case. And also weteringen. Weteringen are the main drainage channels. You can see them on maps quite regularly in areas. So, and of course molens, mills, to drain everything, because there's always going to be wind in the Netherlands. So if you have a mill, it pumps out all the water. And why I chose this picture of the area is that it's very clear to see that they came from two different angles. So this is a reclamation base where they started to dig out the peat, and this also. And they met in the middle, and they dug a huge main sloot over here. This is the old border where the farmers on this side, Nes aan de Amstel, and these farmers met the farmers who lived on the Waver, and started going up from there. And now, of course, it is one of the main canals to drain the water into the Oude Waver, which eventually comes into the Amstel, which eventually flows to Amsterdam, drops its water in the IJ, which was by then still part of the open sea. Now, of course, we know it's part of the Markermeer, and of course, the Markermeer eventually loses its water into the IJsselmeer, and the IJsselmeer flows into het Kornwerderzand and the sluices of the Afsluitdijk, eventually into the Waddenzee and into the North Sea. So every rain that falls here moves eventually away through pumping, dewatering. So what we see nowadays when we fly over these, peated landscapes is called in Dutch a slagenlandschap, or a plots landscape. And every one of these is a plot or a slag. This is a slag, and this is a slag, and this is a slag. And you can see them in this map as well. They started here, slag, slag, slag. All of these parcels are called plots or slagen. And this is a typical plot. This is a picture from the book. Okay, a typical plot was usually around 100 meters wide. It's a little less actually, and around a mile long, 1600 meters or so. And a quarter of that plot was used for dewatering. This is how much water is actually in these peated landscapes. A quarter was used for dewatering. That's quite a lot. And as we've seen in the North Sea areas, also in the peated areas, there is the recht van opstrek. So this farm had titles, could claim more of the uncultivated land that's over here if he wanted to. And as we'll see, in fact, he had to in a couple of weeks or months or years. And what they also did was they planted a lot of alder trees. And the alder trees had a double function. It was easy for other farmers to see where the plots were. And of course, in wintertime, there was some extra fuel. So you could chop down a tree or part of the tree and put it in your stove. Or, of course, you could make, a new table out of it or furniture. So it was, it had more than one function. Now, in this area, I want you to get, a feel for the terms the terminology when we are referring to these plot landscapes. First of all, there is the river in the mire. This is the drainage channel. Okay, all the water that falls on these cushions of wet cushions of uncultivated peatland area, where we see erroneously a cow. This cow cannot live here, so it wouldn't be there. But all that water is going to eventually have to end up here in the drainage channel. Now, of course, this is a reclamation base. This is from where they started to walk into the peatland area. And of course, this is the first plot that they made, the eerste slag. And once you've established this, you immediately had the right of the recht van opstrek to eventually cultivate this as well. And these are called the wildlands, or this is the mire that we saw. So back in the high Middle Ages, let's say 1200, 1300, this was the situation. Okay, drainage channel over here, reclamation base over there, the first plot and a field. And people were getting out the turf from the soil and selling it. And there were alder trees, and it was beautiful. Okay, and there was some uncultivated land, which was just a mire. But the problem with these very wetland areas is that, if we think about it, like I said, the groundwater that falls over here has to flow over there. And this is a lot higher than that. So a lot of this groundwater that falls over here immediately flows through the field. And when it rains a lot, the field is going to have problems. Why? Well, if it is wet and there's too much water, then you will have rotting roots. The plants on your field, they will start to root in too much water. The roots will react with the water and the oxygen, and that you'll have fungi and you'll have rotting roots, and the crops will fail, and you'll have very, very, very low yields. Now these guys or girls over here, they of course had to make a little money. And they would sell their turf, and they could sell some of the alder tree woods. But, they would also like to earn a little more. And these fields were really necessary for them to actually make a little bit of money. So if you have very low yields because your crops are failing, what do? You try to get rid of all the excess water that are causing all of these problems. So mills were built, dewatering, more drainage channels, and you start to pump all the water in this area. This is a beautiful star-shaped. This is the reclamation base, and then this is the drainage channel, and all of the water from this area had to leave this because we need dry fields. Okay, the people started to influence the groundwater level and the flow of the groundwater. But the problem is, if you have these peat plants, they act like sort of a sponge. These mosses, we've seen them before in another video. They pack a lot of their volume in water. Okay, that is huge amount of the volume of these plants is going to be water. So if you're going to extract a lot of water from the mire, you're going to lose a huge deal of volume. And these packages, these sponges of a peatland, they are going to compress into, less volume areas. So you're going to lose a lot of your height. The more you pump the water out, the more volume you're going to lose. And this is known as consolidation. And a lot of soil types do this. Clay does it a lot. Peat does it in huge amounts because these plants, they pack so much of their volume in water. And sand doesn't do it as much. In another episode on Zealand, we'll see what happens if you have clay consolidate more than sand. And you get relief inversion. We'll see that. We'll see what that is later. But for now, it's important that you understand that if you take out the water in a soil type, water takes up space, and in peat it takes up a lot of space. And so if you extract a lot of water, the peat is going to lose a lot of space and become smaller. And that process is called land consolidation. You're going to lose altitude. So what happens is, in phase 2, this area that used to be the field is now lower than it used to be. And the groundwater flow is still from high uncultivated land all the way over here. So your field is going to have more problems with water because water flows to the lowest point, right? Due to dewatering, the land consolidates, the field becomes lower, the more water flows to the lowest point. So more dewatering leads to a lower field, leads to more water flowing towards your field, leads to the necessity to pump more, leads to more water coming in. These guys were pumping themselves down, and eventually they have to move the field away from the area of the first plot to the second plot. Luckily for them, they had the right of opstrik, so there was no problem. They could just move the field into the uncultivated land. But they had to move the field, and now they had to walk a lot further, 1,600 meters. I mean, that takes me, if I run on top of my lungs, that takes me it takes me 5 minutes roughly. And I'm a pretty good runner, and that's on the athletics track. So it takes a normal person at least 20 minutes walking through a field where there is going to be a lot of mud and water. So they move the field, and guess what happens? They have to move the field again, of course, because, the same problems start to happen here, right? Water from the uncultivated land moves down, and these crops will start to rot, so they have to pump more, and etc., etc., etc. What happens is, in some cases in the Netherlands, and this is pretty unique in the world, is that you have the drainage channel, which is the lowest point here, and which is still the lowest point here, actually not be the lowest point here. They have to pump the groundwater up into the drainage channel, which is crazy. This is now the lowest point. If nothing happens, if people wouldn't pump here, there would be groundwater all the way over here. This would be a lake. People have pumped themselves below groundwater levels for a long time. And these polders, as they are known, places in the Netherlands where the groundwater is heavily influenced by pumping of the water out, artificially dry ground lower than the groundwater level. That's going to be a huge problem. Now, and in some extreme cases, the pumping, which is done electronically, takes up more money than the agricultural revenue from the grassland that is the polder. So some of these polders are actually being given back to nature, and new lakes are formed, and new marshes are formed, hopefully, and then the peated process can start again. Of course, it will take a couple of thousand years to get these huge bulges back of peatland, but these polders that are no longer economically viable, they are being given back to nature, and they get a leisure or a touristic um, um, destination, basically. Now, peat excavation, I've discussed this before, has been done in the Netherlands to a large, huge, even industrial level, because dried peat makes for great fuel. And here we have these blocks of soil, and this guy is basically just excavating them over here. And here they're doing it in the Peel, which is in the Netherlands, in North Brabant. And what they did is they actually just, sort of a train track over here, and they excavate the peat. Now, of course, in the Lower Netherlands, this was done differently because, there's a lot more water there. So what they did is they dredged the peat out of the water with a tool that is known as the baggerbeugel. I don't have the slightest idea how to translate that to English, but I don't think it's possible even. What they did is they dredged the peat out of the water and then let it dry over at the acres over here. And that was going to be your peat. And here you see the mill regulating the ground level here, the water table over here, the water level. And these acres where the peat was laid out to dry in the sun, they are known as legakkers. And so in the Netherlands, you have this situation where there has been an excavation of peat. There are legakkers all the way over here. This is where the peat was laid out to dry in former times. And they're called legakkers, lay acres, literal translation. And peatgaten in the middle. This is where the peat was excavated. And peatgat, I don't think has a literal translation in English, so I'm not going to bother.